Hello everyone, I'm Yang a PhD researcher from Kochi University of Technology, Japan. Today we will talk about text revision designs in VR environments. During the virtualization process of daily office work into VR, we found plenty of scenarios where need effective and useful typing methods. Based on voice-to-text and AI-assisted techniques, users can enter typo-free text quickly into VR applications. In real-life scenarios, we also need to change the entered text to express precise or proper intention. That brings us the question, for virtual reality scenarios, how do current VR typing methods handle text revision? To answer this question, we first did a thorough review on VR typing papers in the last 20 years. We found that researchers mainly put attentions on boosting typing speed and accuracy in VR via proposing novel methods. For text revision, however, is seldom mentioned. Ironically, some solutions didn't include backspace and/or cursor control into their designs. To fill this gap and to make the initial step to explore text revision solutions in VR, we include cursor control and backspace into our consideration. As shown in this slide, for cursor control, we get two options, discrete and continuous, into our design. Similarly, for backspace, we also set character level and word level as two alternatives. Based on these two tools and their options, we turn them into a design space as shown on the right. Every cell of the design space represents a combinational use of backspace and cursor control method. To further validate the design space, we implemented four text revision techniques with the virtual keyboard and handheld controllers. In detail, we used the click and swipe behavior on the physical button or on the touchpad to realize different backspace granularities and cursor control methods. We designed a within-subject experiment with 16 participants to evaluate their text revision performance with four techniques. We also put different types of targets for participants to revise. Every participant needs to revise totally 120 targets with four proposed techniques. Overall, results showed that the combination of word-level backspace and continuous cursor control got the better performance than other techniques in terms of correction time, operation per character, the number of using backspace and cursor control, and user preference. In detail, continuous cursor control leads to less operation number to revise a target. For targets far from the end of the sentence, techniques with continuous cursor control can significantly reduce the workload to finish the revision. Continuous cursor control can reduce efforts to manipulate the caret, especially for far targets. However, it should be noted that participants have to focus on the fast-moving carets to stop the caret to the intended place. Word-level backspace contributes to the less use of backspace during revision, whereas it may also be a double-edged sword to bring potential cascade efforts for recovery to participants if they misdelete more words. To conclude, we first reviewed the lack of text revision in current VR typing designs. Then we propose a design space and text revision techniques in VR. Results of our user study also serve as guidelines for future designers. For future work, we will conduct mass-scale usability study for deeper understanding users' text revision behaviors in VR environments. Based on current results, we will also include AI-assisted techniques and propose novel tools and procedures to enhance users' text revision performance in VR. Thanks for your attention, and please check our paper for more details.